So we've been talking about the Pythagorean theorem. Right triangles. This is a right triangle. Add the little square so you understand, so you realize it is a right triangle. This is leg A, and this would be leg B, and this would be the hypotenuse, which we label C. Okay, so in the past we've said, well, if A is 4 and B is 9, then we square this, we square this, we add them together. So we have 16 plus 81 equals 97. So the area of this square is 97. So that means that the length of this is the square root of 97 because 97 is an irrational number. So continuing along that line, let's try something a little bit different. What happens if I know this side length and I know this side length, but I don't know B side length? Well, we do the same thing that we do with the Pythagorean theorem. We set it up a squared plus b squared equals c squared. This case, I know that a is 4, so I have 4 squared plus b. Oh, I don't know that number. That's okay. We'll just write it. B squared equals, now I know c, so I'm going to say 5 squared. Okay, so now all I do is I take 4 times 4 is 16 plus b squared equals 5 times 5 is 25. Remember, guys, ladies and gentlemen, this is important to have a calculator by your side in order to do this stuff, because calculators are so valuable in the finding lengths in the Pythagorean theorem. So we've done stuff like this in the past. If you remember, we went like this. We said, okay, there's my equal sign. Whatever I do to the left side of the equal sign, I have to do to the right side. So in this case, I'm going to subtract 16 from this side. I'm going to subtract 16 from this side. And I'm going to get b squared equals 9. Now, plugging in my calculator, I find that the square root of 9 is 3. So b is equal to 3. Let's do another one. I'm just going to make up some numbers here. Let's try 42. Let's try 18 and not knowing b. So I get 18 squared plus 40, oops, I almost did it myself, plus b squared equals 42 squared. Sorry, had to get my calculator. I tell you guys to make sure you have a calculator at hand when you're doing it, and I didn't even have mine. Okay, so I have, plugging it into my calculator, I see 18x squared is 324. We'll leave b squared where it is, and now we'll say 42 squared is 1764. Okay, so now we'll solve equations. Subtract 324. So I get 1764 minus 324 is 1440. So I get b squared equals 1440. Okay, so now remember, to get rid of the squared, we take the square root. So I take the square root of 1440, and it is 37.90. I don't have to do that anymore. So guess what? My actual length is simply written square root of 1440. So that means that this length is the square root of 1440. Okay, let's do another one. What if I had the square root of 96 and the square root of 48, and I didn't know b? Well, I have the square root of 48 squared plus b squared equals the square root of 96 squared. Remember, parentheses are important, especially when you're using a calculator. However, because we've learned this in the past, we know that when we square a square root, we get what's left underneath. So we get 48 plus b squared equals squaring a square root gives me 96. So now I'm just going to go ahead and solve like I have in the past. Minus 48 minus 48. I get b squared equals 48. So we'll go ahead and take the square root. Square root of b squared is just b. Square root of 48 is 6.9. Oh, wait, I don't need that. If it starts with a decimal, I'm just going to leave this as the square root of 48. So let's try one more possibility that we may see. Let's say that this is 13. This is the square root of 8. Let's find out what b would be. So we're going to do the same thing. Square root of 8 squared plus b squared equals 13 squared. So I get squaring a square root leaves just what's underneath. 8 plus b squared equals 13 times 13 is 169 minus 8 minus 8. I get b squared equals 161. Taking the square root of both sides, I get b, and the square root of 161, 12.0 decimal. Don't have to worry about it. Just ignore it, and we're just going to leave the square root of 161. So b is the square root of 161. It's called an exact length.